hydrogen bonding. This also is a topic that deals with thermodynamics, and it also is related to the ideas that we talked about before in terms of thinking about different types of bonds. So if we talk about a hydrogen bond, first I just want to be really clear, is not a covalent bond. So this HX bond here is a covalent bond. This is not a hydrogen bond. But a hydrogen bond can form when you have a partial positive on a hydrogen and you have what's called a hydrogen bond donor atom, which has a partial negative on it and also has a lone pair. Typically, this Y atom will be on a separate molecule. And what happens is you have that Coulombic attraction between the partial positive on the hydrogen and the partial negative on this hydrogen bond donor atom. So what you form between them is a hydrogen bond, and you'll notice that I drew it as a dashed line. H bonds or hydrogen bonds are drawn either as dashed lines or as dotted lines, and they're done so to differentiate them from covalent bonds, which we draw with this straight line here. So let's think about what can form hydrogen bonds. First of all, there's a requirement for what this HX bond can be. It has to be a really electronegative atom in this X here because we need to form that partial positive on the hydrogen, which means that the atom that it's covalently bonded to needs to be pulling away some of that electron density from the hydrogen such that we have a delta positive on the hydrogen atom. Similarly, the same atoms are what can be the Y here, so it can either be a nitrogen, an oxygen, or a fluorine. So these are the only hydrogen bond donors that can form H bonds. And we can think about the reason for this, and the reason is pretty straightforward. We need to have a small atom, but it also needs to be really electronegative. This should make sense because we need to have this partial negative charge here to have that Coulomb attraction. And the other requirement is that we definitely need to have that lone pair of electrons so it can actually interact in this hydrogen bond here. So let's take a look at an example of a hydrogen bond, and that's between two water molecules. So let's go ahead and redraw our water molecules. They're just kind of randomly oriented there. But let's redraw them as if they were going to have a hydrogen bond between them. And one thing I want to point out about hydrogen bonds is that they're strongest when you actually have all three atoms in a straight line like this, because it keeps the dipoles the strongest, so the partial positive here and the partial negative here can interact. So let's redraw our water molecules like that. So we have our first water molecule here, and let's say we're going to be talking about this hydrogen in terms of hydrogen bonding. Obviously, we have 4 hydrogens up there that can take place or take part in H bonding, but we're just going to focus on this one here. So that means we want our straight line to be something like this to our second oxygen. So let's draw the hydrogens on this water molecule as well. All right, so thinking about what the Lewis structure of water is, how many lone pairs do we have on this oxygen here? 2 lone pairs, great. So let's draw those in. And let's draw these lone pairs in as well. All right, and we're going to be talking about these 2 atoms in terms of our hydrogen bond. So does this have a delta plus or a delta negative on it? Delta plus. So this is a polar bond here, this OH bond. So we have a delta plus on our hydrogen, and we have a delta minus on our oxygen. So these also have delta pluses, of course, and this also has a delta minus. So because these 2 can interact and they're lined up to do so, what we can do is we can draw a hydrogen bond right in between this hydrogen and this oxygen atom here. So again, I pointed out that, in fact, hydrogen bonds are not as strong as covalent bonds. Since they're not as strong, if you remember thinking about the relationship between bond strength and bond length, would you expect a hydrogen bond to be longer or shorter than a covalent bond? Good. OK, it should be longer here. So this is our longer bond because it's our weaker bond. They're not held together as tightly. All right, so this is an example of an intermolecular hydrogen bond. It's between two different molecules. Hopefully you can also see that if we're focusing on any single one water molecule, we could also form hydrogen bonds between other water molecules with either of these 2 hydrogens as well, and also with our other lone pair here. So any water molecule can actually form 4 different hydrogen bonds. All right.